Good evening and welcome to July's Comet Watch. It's been a busy month. We did skip a month. Very busy month, I think, for a lot of us, and work kind of does get in the way sometimes. I'm on a completely new shift, so it was I needed to get used to it. However, it is the end of July. It's been a very interesting month, comet-wise, and there is lots more to come this year, I believe. So, um, let me introduce myself. I'm Nick Evetts. Neil.
I'm Neil Norman.
And would our guest this month like to introduce himself, please?
Hello, I'm Don Machholz.
Okay, great to have you with us, Don. Now, okay, so let's get kicked off with the shipping forecast. And it's a 50-50 who gets the most difficult comet to pronounce this month. Will it be me or Neil?
Um,
So we'll
I
start.
wonder.
We'll start with the latest discoveries. Zhejian Zhu reports a Kreutz Comet in real-time C3 images.
On July the 28th, Masanori Uchina reports a Kreutz Group comet in real-time C3 images.
July 31st, Warchop Boomplod reports a Kreutz Comet in real-time C3 images.
August the 2nd was the discovery of 2020-01 periodic comet Lemon Pan-STARRS reported.
On the 2nd still, discovery of 2020-02, Amaral reported.
Again on the 2nd of August was the discovery of 2020-03 periodic comet Pan-STARRS reported.
Still on the 2nd, Warchop Boomplod reports a Kreutz Comet in real-time C3 images.
On the 6th of August, Warshot Bloomplod reports a non-group comet and a fragment in real-time C3 images.
On the August the 7th, Peter Barrett Barrett, I think that is, I apologise if I got it wrong, reports a Mayo Group comet in delayed C2 images.
Again on the 7th of August, Warshot Bloomplod reports a non-group comet fragment in real-time C2 images.
On the 8th of August now, discovery of 2020 P1 Neowise reported.
August 11th was 2019 NJ3 Lemon confirmed as a comet.
Still on the 11th, Michel Bayasida reports a Kreutz Comet in real-time C3 images.
August the 12th, 2020 P2 2009 Q4 periodic Botini rediscovered.
August the 13th, Masanori Uchina reports two Kreutz Comets in real-time C3 images.
On the 16th of August was the discovery of 2020 P3 Atlas reported.
Still on the 16th, recovery of 2011 U2 periodic comet Bressi reported.
On August the 17th, a recovery of 2008 QP20 periodic linear Hill reported.
Still on August the 17th, recovery of 2011 R3 periodic comet Novi Chonk Greek reported.
And again on the 17th is Michel Biasiada reports a Kreutz Group comet in real-time C3 images.
August the 19th, recovery of 2002 T5 periodic comet linear reported.
August the 20th was the discovery of 2020 Q1 Borisov reported.
August the 21st, Sergei Shurapakov reports a Kreutz comet in real-time C3 images.
August the 25th, Warshot Bloomplod reports a Crack Group comet in real-time C2 images.
Still with August the 25th, a new user and Payan Sun reports a Kreutz comet in real-time C3 images.
And August the 26th was the update.
So now we're going to move on to current comet magnitudes and observable region. So I'll kick off with our good friend 2020 F3 Neowise, magnitude 8.5. It's beginning to fade. Observable 50 degrees north to 75 degrees south. It's an early evening object. The last visual observation was 2020 August.
Next up is 88P Howl, magnitude 9.5 and brightening 40 degrees north to 85 degrees south, an evening object last reported in August 2020.
2020 K8 Catalina Atlas, 10.5 magnitude, steady, 40 degrees north to 30 degrees south, early evening, last visually observed 2020 August.
And the old favourite 2019 U6 Lemon, magnitude 10.5, sadly now fading, 55 degrees north to 55 degrees south, an evening object, last reported in August 2020.
P2P Enki, magnitude 10.5, fading, 25 degrees north to 90 degrees south. It's an evening object, last visually observed August 2020.
2019 N1 Atlas, now magnitude 11 and brightening, 50 degrees north to 5 degrees north, early evening object, last visually reported in August.
27 T2 Pan-STARRS, 11th magnitude, fading, 55 degrees north to 55 degrees south. It's an evening object, last observed, visually observed 2020 August.
Next is 58P Jackson Nugmin, magnitude 11 and now fading, 45 degrees north to 50 degrees south, a morning object, last reported in August.
2020 Q1 Borisov, 12th magnitude, bright, 65 degrees north to 25 degrees south. It's a morning object, last visually observed August 2020.
29P. Swashing Vagman, I believe. Magnitude 13 question mark, although has recently had an outburst and varies 55 degrees north to 35 degrees south. Best viewed in the morning. Last reported in August.
I have to admit, this is probably the only comet that I know that actually has a genuine London address, SW1. Okay, 2018 N2 Assassin, 13.5, fading, 55 degrees north to 30 degrees north. It's an all-night object, last visually observed January 2020.
And finally, the exciting comet is getting onto the table now. 2017 K2 Pan-STARRS, magnitude 14.5 and now brightening, 55 degrees north to 10 degrees south, an all-night object, and last reported in August 2020.
Now, I've actually recently imaged this, as you know, Neil, and
Absolutely.
it is still, well, I was using, just trying to remember, a 0.5 meter telescope, and I was also using a 14 inch, and it's still very difficult, even with a CCD, to capture. It's very faint, to my mind, in CCD images.
But it's still near Saturn, isn't it? So,
absolutely, yes.
So, and we've been, we've had it in our eyes now for 3 years, and I've been told we could possibly keep it under observation until 2030, perhaps.
It will certainly be good fun if we can. So anyway, details are usually updated at the beginning of each month, but may be updated more frequently for brighter comets. The last partial update was on August the 26th. The observable region is an approximate indication of the latitude the comet may be seen. Obviously, under good conditions, comets may be visible outside this range. The period when visible is for the UK, and if the comet is visible from the UK, otherwise for the 40 degrees south or the equator as appropriate. As always, the last visual observation is as received by the section. Charts are often updated, and details are too, on the basis of observations published elsewhere. And I will say this, beginners will find comets fainter than 7th magnitude very difficult to locate. You really do need to know your way around the stars, and that is where a good star chart and learning to star hop does come in, certainly around the constellations. What I will say is I want to thank Jonathan Shanklin and Nick James, as always, for this great website. Well, we have a very fascinating guest this month. Oh God, I'm definitely sounding like Patrick then. Sorry, but as I say, we'll get the rest of the show out of the way. Don, welcome to CometWatch.
Well, thank you for inviting me. I really appreciate this.
Now, you actually have as I understand it, probably the most number of visual comets.
Yes, that's correct. 12 visual comet discoveries that bear my name.
Okay, because I also happen to know that you wrote a really interesting book on an observer's guide to Comet Hale-Bopp, and you are one of the co-inventors, so to speak, of the Messier Marathon.
Yes, I've written a few books on that too.
And of course, Messier's catalogue, as most people who are really into comets and stuff knows, it was purely written so he could actually confirm that the fuzzy blob he was looking at was or wasn't a comet. And of course now it's one of those fun things that takes over an awful lot of remote telescopes in the spring and autumn. And everybody gets Messier marathon fever, so to speak, and it's good fun. I will say that I tend to do random Messier objects, and I quite enjoy it occasionally. But and of course you also write for newspapers in California about astronomy and comets.
Yes, I did when I was living in Northern California, but since then I've moved to Arizona.
Now let's okay. Now I'm just pulling up some stuff here because so we can get going. Comet. One of the comets you discovered, 96P, is also one that orbits the sun about every 6 years. Could you tell us a bit about that?
Yes, that was my third comet discovery on May 12th, 1986, about 2 degrees south of the Andromeda Galaxy in the morning sky. And when I first discovered it, it was simply known as Comet Machholz. It took about 3 weeks before Dr. Marsden got enough data to realize it's a periodic comet. Comes by every 5.24 years. At the time it was discovered, it was the closest periodic comet that went closest to the sun. It has a highly inclined orbit, about 60 degrees. Its orbit is always changing. It goes through about a 4,000-year cycle on a complete change of its orbit. And it seems to have caused several major meteor showers and a total of perhaps 8 meteor showers, most of them minor. And it seems like a couple comet groups have been produced by this comet or been produced at the time that this comet was made.
Now, if I remember my meteor showers right, it's suspected to be the progenitor of the Delta Aquarids.
Right.
Because, well, at the moment, the comet of origin, as NASA has it, is unknown, and then it says 96P suspected. So it's active in July and August, between the 12th of July and the 23rd of August, and it's approximately 20 meteors an hour. So it's quite a nice. It's better seen in the southern hemisphere as well.
Right.
So I'm sure quite a few people who are listening to this show are going to be smirking at that one. But it can't have everything. We've had a decent showing. Go on, Neil.
I was going to say, Don, it's actually interesting how you discovered this comet, isn't it? Because you actually were using giant binoculars that you made yourself.
Right. This was my homemade binoculars that I made in 1983 out of 2 large aerial photography lenses. The front lenses measure 6.2 inches across, but it acts like about a 5 1/4 inch pair of binoculars at 29 magnification. And I used that for 4 of my comet discoveries.
Wow.
Actually, binoculars are supposed to be quite good for comets anyway. I know that George Alcock used a pair for his discoveries, and he was also a visual observer.
Right. When you use 2 eyes, you can increase the contrast.
Yeah. I think that's why a lot of people are actually switching to binocular adapters for some of their telescopes, so that that way they have a better chance of getting more information from the available photons as well.
Yes, for comet hunting, light grasp is important, but contrast is the name of the game, because we are sweeping usually down near the horizon, usually under 20 degrees high. Quite often in the last year, I've probably average 14, 15 degrees high down to 4 degrees high sometimes. So you have a bit of haze. You're also looking for a low contrast object.
Now, I understand, well, this is something Neil brought up before we started the show. You actually do a podcast, don't you, as well?
Yes, it's entitled Looking Up with Don. I began it this beginning of this year. We record number 34, I think, coming up this week. Mm-hmm. It drops every Wednesday morning or Tuesday night, and I talk about what's going on over the next week up in the sky, beginning with the moon phase, which kind of affects everything that you can see. If you have a bright moon in the evening sky, we don't usually go after comets in the evening sky and so on. I talk about the visibility of the International Space Station and what you can expect if you want to go out and see it over the next week. I then bring up some topic usually related to comets, but not always. Then I do talk about comets, and I talk about the Messier Marathon from time to time. Right now we're doing a series which every 4 weeks or so I talk about the Messier Marathon, and if you want to do it this time of the year, where you would start and where you would finish. Over the next few weeks, I'll be discussing a book that I wrote in 1985 entitled A Decade of Comets. It was a 110-page study of the 33 comets visually discovered between 1975 and 1984. And in fact, I'll be making the book available for free download on my website in conjunction with the podcast. And we'll be taking, I think, 8 or 9 weeks to go over the...
Sounds interesting. I shall keep an eye out for that.
Quite definitely.
Read.
Yep.
So your first comet was back in 1978.
Yes, September 12th, 1978. And I was comet hunting from a place that I spent 15 years comet hunting from, which was Loma Prieta, which is a mountain in the Santa Cruz Mountains in the central California area, kind of between San Jose and Santa Cruz. Mm-hmm. And I'm at 3,400 feet, which is about 1,000 meters high. And I would commute there from San Jose. It's a 40-minute drive, and set up my telescope and comet hunt. And on September 12th, I was sweeping the southeastern sky just about at the time of twilight. And 2 degrees south of the star Sirius, I picked up a little fuzzy object. And I knew the sky well enough to know that this should not be there. It's not a galaxy, and it's not a nebula. But I still checked the charts, and there was nothing there. So I knew at that time this looks like a new comet.
And of course, then your next one was 1985.
Yes, and that took 7 years and 1,742 hours. My first one took 1,700 hours. And when I told Dr. Marsden that, he says, well, I guess that increases everybody's number of hours by like 1 hour. So my second one took almost seven years, and it was discovered not at Loma Prieta, but at Big Bear, which is in Southern California, where I was at a astronomy convention. And that comet was found again in the morning sky, about 8.5 magnitude, and I had to drive 10 hours home that day and report it, and it was confirmed the next morning.
Neil?
Well, that's amazing. I mean, the amount of dedication. I mean, I think your most prolific year was 1994. I think you had 3 discoveries and 2 very quickly together, weren't there?
Yes, 3 discoveries in 4 months. And yeah, I didn't really do anything any different that year. I was just doing my comet hunting. Now, those comets were found fairly far north, and I do cover the northern part of the sky, probably more than most comet hunters do. But that was quite a time. The first of those three comets, I picked it up and I notified Dr. Marsden at the Smithsonian. I believe I probably sent him an electronic message first. And I'll do that because they don't get into work until 9 o'clock their time and 6 o'clock our time. So I send the electronic message, and then when he gets to the office, I'll call him. And this was a fairly easy one to confirm. I said, I believe I picked up a new comet. Here's the position. And he says, oh, yeah. He says, we got a couple observations from Japan overnight about this. So number one, number two. So it looks like you'll be number 3 on it. So give me the position and the magnitude, and that'll be it. So that was an easy one to confirm. And then 5 weeks later, I picked up another comet, which turned out to be periodic Comet Machholz 2, P151, which was recovered within the last month from, actually, Pan-STARRS picked it up and thought it was an asteroid because it doesn't have a coma yet. No. And then they realized, oh, this is P151 coming back, last seen in 2015. And so it comes around every 5.25 years, much the same time period as my first one, but they're about 2 or 3 years offset. So every 2 or 3 years, you have a periodic Comet Machholz in the sky. Yeah. This one broke into 5 parts, consisted of 5 parts, and it was a surprising comet. Every time I turned around, something was going on with this comet. I picked it up on August 13th. By August 19th or 20th, there were reports that it had outburst and become even brighter. And then as the moon got out of the sky and those CCD guys get in there, Michael Yeager and others, they began to find these components. And one after the other, every other day, they found a new component. So, and a debris trail between the components. So this was a pretty odd comet. And then as we entered into October, the bright one, which I had discovered, which is known as Part A, dimmed a little bit, and Part D brightened a little bit. And so we had 2 comets in the same field of view, about 9th magnitude of equal brightness. Yeah. And then on October 8th, I discovered my 3rd comet of that year. And that was a rather faint one, fairly high in the sky, 55-degree declination. And that's one of those probably 3 comets that if I had not discovered, would not have been discovered at all. That one didn't get very close to the Earth nor Sun, nor did it brighten very much.
Don, could you take us through how you set up for the evening and how you actually do your observations when you're at your binoculars?
Sure. Yes. Beforehand, I decide where I'm going to sweep. And the sky has 40,000 square degrees. And when I put together my comet hunting theory, there's 3 things that you have to do if you want to discover a comet. And the first is you have to be looking at the comet. You have to be looking in the right place. And right now, presently, and for the last few years, I go to the Smithsonian's website, Astrophysical Observatory's website, and see what the sky coverage is. So I know what those guys, the Pan-STARRS and Atlas and everyone else is looking. They do plot on a map where they have looked each day, and I get about the last 10 days of data. So I tend to avoid the places that they search. And by the way, in the last few years, they've been covering more and more of the sky, leaving less and less that's uncovered. And most of my sessions are in the morning. Over 85% of my sessions are after midnight. So I'll get up, get dressed, go on out, set up the telescope, and start sweeping. I'll plan beforehand what part of the sky I'll start at, and I'll use my electronic setting circles to place it there, and where I'm going to end. My sweeps used to be, with the 18-inch, 15 degrees in declination in length. I sweep horizontally. So I might start at 30 degrees declination and down to 15 degrees declination in a horizontal manner, which is a sweep of usually around 20 degrees depending upon where I am in the sky. And that will take about 2.5 or 3 minutes. Then I'll swing the telescope back to the beginning area, drop it just a fraction of a field, and sweep again. I find when I do that, however, if I go out and start at, say, 15 degrees high, after an hour and a half, I'm only 13 degrees high, which means I'm not covering the areas closer to the sun. So for about the last 6 months or so, I've been doing sweeps of only 10 degrees declination, starting at, say, 30 degrees, going down to 20. That's a sweep of 12, 13 degrees. Complete that in under 2 minutes. Drop the telescope now a quarter of a field or a fifth of a field, and then resweep. And then I can positively work my way down toward the horizon. The key is to cover the sky thoroughly and not miss any areas. John Bortle mentioned that years ago. He said, better to cover a small area thoroughly than a large area and not do a real thorough job. And to get down to near the horizon by twilight, which for me is not astronomical twilight, which is when the sun is 18 degrees down, and it's not nautical when it's 10 degrees below the horizon. I call it comet twilight, when the sun is 15 degrees below the horizon. And I determined that 20 years ago when I calculated all the times I began and ended my comet hunting sessions and compared that to where the sun was. And I found that I would usually begin and end my comet hunting sessions when the sun was about 15 degrees below the horizon. In the morning sky, I can go longer than that, and I have, until the sun is, say, only 10 degrees below the horizon. But by then, the sky has brightened a bit. You won't find any 11th or 10th or 9th magnitude comets that way. But you might still be able to find something that's 6th, 7th, or 8th magnitude that is outside of the Swan area, outside of the Soho area, and outside of the big search surveys.
I do believe that one of the observatories down in South America, that's their philosophy as well. By searching below the bottom of where the big surveys go, that's where they found some of their comets, the sonar comets. So it's still very much an area where comet hunters can certainly look and have a very good chance of finding comets.
Yes, and we not only have the big search surveys, we also have amateur astronomers, some of whom used to do the visual comet hunting, and they saw the writing on the wall, and they switched over to CCD comet hunting. Fujikawa, very good comet hunter and discoverer from Japan, co-discovered the last one that I visually discovered, and he was using a CCD. Iwamoto, he uses a CCD, and he also heads as close to the sun as you can get. They can also see fainter with their CCDs than I can with my visual 18-inch telescope. On the other hand, I can usually cover a larger area than they can.
And of course, you have the advantage that once it starts getting really bright in the sky, CCDs tend to get a lot of noise, and you don't get that noise with the Mark 1 eyeball.
No, you don't. But you do have reduced contrast, and again, contrast is the name of the game. So I finish my session. I write down my ending points. I keep a lot of formal log books. I write down how many meteors I saw through the eyepiece and the magnitudes of each of them, and the number of satellites I saw, and all the deep sky objects that I saw.
Neil?
Yeah, I was just wondering about a comet that you discovered in 2004, the Q2 comet. That was quite a bright one, wasn't it? 3.5 or up to magnitude 3 in the end it got to?
Yes, and it was probably my most observed comet. And when people in the general public talk about Comet Machholz, that's the one they refer to. Picked it up on August 27th, 2004, southern hemisphere. And I was living in Colfax, California, and I was using my 6-inch telescope, 6-inch reflector. It's a Dynoscope made by Criterion, the one I got in 1968. And I had modified the eyepiece. The eyepiece holder is designed for a 1 1/4 inch eyepiece, but I used a plumbing tube, a rubber tube, to fit a 2-inch eyepiece to that 1 1/4 inch eyepiece holder, so that all the light that came out of that eyepiece holder went into the eyepiece. That gave me a field of view of 1.8 degrees and 36 power. And that combination is really good for picking up faint objects. And this comet was about 11.2 magnitude when I picked it up.
Yeah.
The orbit kept it outside of our Earth's orbit. It didn't get that close, but it was intrinsically a rather bright comet. And it's probably best known going up through the constellation Orion in December of 2004, and then January 7th and 8th passing by the Pleiades in 2005. And it had a green color too. A lot of people commented on that.
It does seem that we're getting an awful lot of green comets anyway at the moment as well, which is interesting. Which is your personal favourite of your comets?
Personal favorite would be 96P. As Bob Berman, who writes for Astronomy Magazine and sometimes is on SLU, he said this several times. This is probably the strangest comet ever discovered. It might have come from a different solar system too, for all we know, because it lacks carbon. It's a different type of makeup than most comets. So it's kind of an odd comet. It's also the brightest periodic comet. No comet gets to second magnitude on every visit to the sun. This one does. Unfortunately, it's so close to the sun, when that happens, you can't see it from the Earth. But SOHO has picked it up 5 times so far, and it's put on a good show on SOHO.
Yes, I remember there was an article about that back in November of 2017 about SOHO spots not 69P, the return visitor. I will put a link in to the show notes about that, because that was a rather interesting article as well.
Mm-hmm. It's part of what's known as the Machholz complex, which it's a thing. I mean, you can Google Machholz complex, and it actually comes up. But this comet is tied to perhaps an asteroid, which may be responsible for the quads, meteor shower, 2 comet groups, the Croc and the Marsden one, possibly the comet of 1490, but they think 96P has been around for longer than that, so they don't really know how it's tied into 1490. And then 8 meteor showers, most of them minor. In the daytime, Ariads, which are on June 8th. That's in the morning sky, elongation 25, 30 degrees, and it's supposedly the strongest daytime meteor shower, and this comet seems to be responsible for that too.
Yes, I have to admit that was one of the very interesting things that came out about which comet was actually the parent of some of the meteor showers that we've got used to. And of course, we're still figuring it all out. In fact, in a time where we have asteroids that can turn into comets and comets that can turn into asteroids, it's certainly keeping everybody on their toes, particularly since one moment you think you're actually looking, oh, it's just another asteroid, oh joy, and then suddenly it starts growing a tail and it starts putting on a light show for us, and it's like, oh, where did that come from? Some people think maybe there's not enough excitement for the comet. The comet's not getting excited enough at that particular point of discovery, until it gets further into the solar system, and then it starts to sublimate and starts growing tails, which makes everybody think twice about what they're actually looking at.
Yes. One wonders how many of the typical asteroids between Mars and Jupiter would appear cometary if you brought them into Mercury's orbit.
And of course, how many are simply dead comets that have been around the sun too many times and got too close. Most of the volatiles have gone. There's perhaps some rocky material that's still there, and it gets caught perhaps by Jupiter or by Saturn, and it then starts to become a local resident. It's, I think, probably one of the most interesting times we've ever lived in for comets, because we're learning so much about them, and even what we thought was the last word in comet research is suddenly being turned on its head. I remember hearing that one person was actually rewriting their book about comets at the time of the Rosetta mission, and by the time Rosetta had finished, they just stopped doing it because everything was out of date. Rosetta turned everything comet-wise on its head, and we were learning suddenly comets are a lot more surprising than we thought, and we just can't simply say, oh, it's made up of this, that and the other, because sometimes they'll just turn around and completely throw us a curved ball almost.
Yeah, we say a comet is a dirty snowball, and yet if you've lived in snow for a while, you know there's a lot of different types of snowballs. Some are hard, and some are soft, and some are fluffy. Some have more rocks in than others, and that's how comets are. No two are the same. Two of the first four comets that I discovered disintegrated when they went around the sun. So I guess they were kind of fluffy comets. Not a lot to it. On the other hand, 96P goes 8 times closer to the sun than we do every 5.25 years, and has for a long time, and it survives. So, we say a comet's a comet, but each comet's different. And we're also learning that comets on different returns will act differently. For instance, so 141P recovered here this past month. No one knows how bright it's going to get or how many pieces will be there when it comes around the sun. And when I discovered it in 1994, it probably had outburst in 1999. When it came back, it was a couple magnitudes fainter. And so it varies in brightness depending upon how much it's broken apart in the previous years. So yeah, comets are odd.
And of course,
they are.
I think that's probably the best thing about them. Nobody can predict what a comet's going to do. Everybody sits down and you see all these lurid headlines in the papers. Greatest comet of the century for the last 300 years, blah blah blah, and it just fizzles out. It makes its turn around the sun, gets a little bit too close, and not very much survives when it comes around the other side.
Yeah, we were lucky. I was going to say we were lucky though with one of them, weren't we? Because of course the Neowise comet got very close to the sun and performed very nicely. Do you think that was a great comet, Don? Because in the northern hemisphere we've been rather robbed of naked eye comets since Hale-Bopp in '97, a real decent comet with a nice tail, dusty comet. Do you think it's up there, or do you think we're just grabbing at it because it is the best we've seen for so many years? That's
what I was going to say. It depends how long it's been since you've had a good bright comet. I mean, when Yakutaki came along in '96, it had been 20 years, so everybody was hungry for anything they could get. Yakutaki was a great comet. Hale-Bopp was a great comet. Neowise was a pretty good comet, and it really filled the time slot well. I mean, it was well worth observing, And a lot of people, that would be the best comet they have ever seen because they perhaps missed the ones in the late 90s and since then, and did a decent job. As I said, we had Comet Atlas that was supposed to be bright. Comet Swan was supposed to be bright. And those comets that go kind of close to the sun, they can make it or break it. The Bortle limit, invented by John Bortle, will compare the perihelion distance to the absolute magnitude of the comet. And he can, with that table, somewhat predict whether a comet will survive or not. It has to be a certain absolute magnitude or brighter if it's going to go within a certain distance of the sun for it to survive. And that's one tool that we have to help determine whether or not they'll survive. But as you said, every comet's different.
Yes.
Yeah, I know that the Bortle thing has been used an awful lot more amongst amateur astronomers, because on the CometWatch Facebook group, we're actually, every single comet, there's one person in particular who's finding all these new comets that are coming around, like the new NEO-WISE one, the 2020 P1. And we're looking at the Bortle limit and we're thinking, oh, well, yeah, this one doesn't look like it's going to survive, and Atlas probably wouldn't have survived. And now we can almost predict it. I know comets are very, like we've been saying, very unpredictable, but we're getting better at what we're doing, and more amateurs are grabbing onto this stuff. I mean, years ago when I first started, we didn't think about, survival things until, all of this sort of tables were done. So it's quite good now how we're actually making the good science amongst the amateurs.
Yeah, the amateurs have done a good job. Look at Halley's Comet when it came by, all the thousands and thousands of magnitude estimates put together by the amateurs. We do a good job.
I suppose in some respects the amateur astronomy community has the biggest advantage over the professionals, is that we have the instruments and we have unlimited time on these instruments, really. So once there's a comet been posted and the details are known, the orbit's roughly available, we can get out there, we can look at it, we can image it, we can do pretty much do everything the professionals can do. The only thing we can do that they can't is, of course, we can nail down huge tracts of time just to one object, which is, well, I think a lot of more of the professional amateur collaborations are really going to happen, certainly over the next few years, because we can provide the professional community with literally hundreds and thousands of observations, and in a scientific manner, that they can actually take the information and use it for their projects and for their studies.
Yes, and the better the relationship between the amateurs and the pros, the better off we'll be. We as amateurs need to know what it is they want.
Yeah.
And we need to know then how to give them that information.
And as it was pointed out to me, yes, great, you got a nice colour image of SW1, but we really need a black and white one, a luminance picture, because it allows them to do photometric measurements of the comet much easier. So again, once that information gets out there to the community, it spreads and people realise, okay, colour pictures are brilliant, but the luminance images are really the ones that the scientists want. Now, this means that SW1 is one of my favourites, along with Hawley's. It means that we can actually talk about sending space probes there, because we know what the environment is like. We can time the outbursts. We can tell them how bright it's going to get and how dim it goes. And we are providing the people like NASA and ESA with literally everything they need to plan a space mission. And that is the biggest thing. Can you guarantee the period before outburst? can you give us an idea of the changes in the comet, in the locality of the comet? How much material are we looking at outgassing at any one time? This is stuff that they would need to have the larger instruments dedicated to for a long period of time. We in the amateur astronomical community, we can go out night after night. We have the training available to us through organisations like the Association of Lunar and Planetary Observers, the Astro League, the British Astronomical Association. All those groups provide good, solid training on how to do imaging for science and how to record visual observations for the scientific community to use at a later date.
Yeah, that's right. And the few things. One, SW1, who would think 10 years ago that people would actually be able to start predicting when it's going to outburst? But now we have people doing that.
Yeah.
We look at the meteor showers that's beginning even back in 2000 with the Leonids. You had astronomers predicting when and where the greatest number of meteors would be seen, sometimes accurate to within a few minutes, based upon the orbital paths of these comets from years and decades and centuries ago. It's amazing some of the predictions that people come up with.
Well, you mentioned Dr. Marsden earlier. I know that one of the things that one of the notices was if it moves or explodes, Marsden wants to know about it. And this was a guy with a pen, originally with a pencil and paper, who was taking the observations and actually creating orbits for astronomers to go back out and check and send back the results so he could refine. And he was only using, I would assume he'd probably use a desk calculator as well, and then obviously he got a computer that would help him with it. But this guy was sitting at a desk with basically traditional materials, and he was churning out orbital information that was allowing verification of comets, allowing people to actually send back the information required really to ultra refine it. Now we can look back into the past using Dr. Marsden's results, using the computer's results. We can look forward or we can look backwards, and we can actually say, well, this would have been seen, but this may have been what was seen in such and such in such country, in one of the, in either in a poem or in a story that was that recorded the actual event, a genuine historical event in a fictional setting.
The astrometry, which amateurs are able to do, has grown and grown over the last few decades. Astrometry is being able to produce very accurate coordinates for a comet. Back when I discovered my first comet in 1978, we had to wait for the professional observatories to photograph it and then measure it on their plate and get an exact position. And you needed 3 positions to begin to calculate an orbit. By 2004, with my 10th comet discovery, boom, those amateurs were there getting images from day one.
Yeah.
And hundreds of positions would pour in the first couple days. In 2010, with my 11th comet discovery, 11th magnitude comet, fairly faint, kind of close to the sun as seen from the Earth. Same thing, those amateurs get out there and they get those exact positions. And within less than a day, sometimes maybe as long as a day and a half, you have a preliminary orbit, which turns out to be surprisingly accurate as more positions come in. It's just amazing what the amateurs have done with the astrometry.
We've seen that a lot recently. I remember Terry Lovejoy, he announced the comet, I think it was the 2014 Q2 comet or Q4, whichever one it was. and he announced it on Facebook that he thought he found one, and then I remember some guys in Argentina, I think it's Andreas Chapman, went out that evening and he bagged it as well to help confirm it. And there's an orbit within sort of like 4 hours of Terry original post, and literally boom, boom, boom. It's unbelievable. You know, you can follow it all through the day. It's crazy.
Yes. As a comet rises around the world, more and more positions come in. It is amazing what happens.
And of course, in some respects, we the amateur astronomy community are becoming as well organized as the big surveys are. Really, okay, we can't beat them when it comes to discoveries. But we are, as we can contact each other, we can say, hey, I've seen this, these are my coordinates, can you go out tonight, can you have a look for it, can you image it, and hand it on to somebody else who can then get another piece of the puzzle, and all can be now fed into the MPC, and then it just literally, maybe in a couple of days, or even less, we've got something that's confirmed, and someone is obviously very happy because they've got a new discovery, they've got it confirmed, and it's happened now within days instead of weeks or even months.
Mm-hmm. With the comet I found in 2018, I was the guy who visually found it. And a couple of Japanese astronomers found it 14 hours after I did with CCDs, and they reported it on a different website.
Yeah.
But the message I got from the Smithsonian Astrophysical Observatory's Central Bureau of Astronomical Telegrams when I reported it was, go out and confirm it. Well, you know, I can wait till the next day when it rises again and see it again. Or I could try to contact people around the world who I knew who could see it. So I thought, okay, Steve O'Meara is in Hawaii. He used to live in Hawaii. So I contacted him, find out he lives in South Africa, and a tree is in the way, so he's not able to see it. I contacted a few other old comet hunting friends, and most of them were unable to go out the next day due to weather or something. So I was kind of in the lurch. I tried contacting Michael Yeager, never got a response, probably had the wrong email address. So I didn't have the type of contacts I probably should have had to get someone in the world to get a CCD on it, to get an accurate position and nail it down. But the point is, comet discoveries made nowadays are almost always made with CCDs. And those guys have accurate positions from the very start. Me, the visual guy, I have what's known as an approximate position, usually accurate to within a few arc minutes. My time is usually accurate not to the second, but to a minute or two. And the guys who help to put all this stuff in order are not used to that anymore. With Dr. Marsden, Dan Green, back in those days when we all did visual comet discoveries, sometimes Dr. Marsden would contact someone. In fact, it would usually be him or Dan Green who would contact someone and say, we have a report of a comet here. Can you confirm it? And I noticed by by 2004, it was kind of up to the discoverer to find somebody to confirm it. And it's kind of that way now. And you give them a single position. CCDs, you can take images 5 minutes apart and detect motion. With visual comet discoveries, 5 minutes, it won't seem like it's moving much. So you only get one position, and they don't always know what to do with that. So my goal with the next comet discovery is to get a second position. Of course, when you're comet hunting in the morning and you pick it up close to astronomical twilight, you might have only 20 minutes to observe it before the twilight gets in the way and it washes out. So it's not that easy, but it can be done.
Now, I know that you have an asteroid named after you, asteroid 245983, and that was named in your honor back in November of 2017.
Right. CERNUS discovered a few asteroids. CERNUS he's from Ukraine. Great guy. Met him.
Mm-hmm.
We've communicated quite a bit. He discovered 3 comets visually in the 1980s and 90s. One with a pair of binoculars, one with a reflector, and one with a Schmidt-Cassegrain, I believe. So different instruments. And then he began doing imaging to find asteroids. And for most comet hunters and most comet discoverers had asteroids named after them in the 1980s, 90s. I remember going to the conventions, and some of the comet people would say, "Oh, my asteroid is this, and my asteroid is that," and they all have 4-digit numbers. Okay.
Yeah.
And I thought, well, I guess, I could be the guy who finds comets and never has an asteroid named after him. I mean, I could live and die that way, and that's perfectly fine. But one day I get an email from CERNUS, and he said, you don't have an asteroid named after you, and you probably should, because everyone else does. And here's 3 asteroids I've found that now are ready to be named, and which one would you like to have? So I sorted through them and said, this one looks good. So he said, fine. I mean, what a guy.
Yeah.
Good friend.
I've actually got one as well. I think Nick's the only one on the show who hasn't got an asteroid.
Yeah, I don't know if Mary has though yet, has she?
No, she hasn't, no. I'm 314650.
Oh, okay.
And I got a random email one day from Matt Dawson, who discovered asteroids in 2006. Yeah. And he said to me, do you want an asteroid? And I said, okay, yeah. And next thing you know, it's on the Minor Planet Centre saying I've got an asteroid. I thought he was winding me up, and he was joking with me, but it's all there. It's all legitimate. Yeah, 314650.
Yeah.
I think I'll have to sell it to Nick. Nick, you want to buy an asteroid?
Well, it depends what it's worth, Neil. Has it got any nice rare metals on it?
Probably.
Now,
20 million. Sorry, carry on.
That's okay. I was going to say could you tell us about the Edgar Wilson Award?
Yes, that was started in the late 1990s. A man's son passed away, and so he named the award in his honor, and it was designed for amateurs who discover comets each year, beginning, I think it's June 14th through the next June 13th. Mm-hmm. So all of those amateurs who discover comets get a share of the award. The award, the amount of the award is based upon 2 things. One is how much has accumulated in the past year, and it's put into stocks and so on. I'm not sure how all that is done. But on June 13th of each year, they pull the money out, or however much they want to use on the awards, and they divvy it up. And amateurs can use CCD equipment to discover comets as long as it's their own equipment.
Yeah.
And if a comet is discovered by 3 people, that comet gets 1 share, and it's divided 3 ways. Mm-hmm. So if you have $20,000 and you have 10 comets discovered, each comet gets $2,000. If you have 3 discoverers, each one gets $667. Yeah. So it works something like that. I'm not sure if it was ever designed to be for visual, because back then, in the late 90s, amateurs were generally finding comets visually, not with CCDs. but it is for amateur astronomers no matter how they find the comets. But they do have to use their own equipment. So the Soho and the Swans, someone who's an amateur using a professional telescope, that doesn't count for the Edgar Wilson Award. And I've received a couple. One was in 2004, and one was in 2010. Now, I should be getting one for the one I discovered in 2018, but the award and the implementation of the award is usually a few years behind.
Yeah.
In 2000, I believe it was in 2004, I wrote a couple letters back and forth to the Smithsonian, and there was some discussion as to who really should be in charge of distributing the award at that center. And it was kind of passed back and forth and so on. So they're actually a few years behind in awarding it. But that's the Edgar Wilson Award. The other award was the Tuthill Award, which was given to Americans and Canadians who discovered comets between 1977, I think it was initiated, up through 1984. And that was put out by Roger Tuthill, who was an astronomy businessman dealer who sold a lot of astronomy stuff, including solar screens, probably known best for that. And it included a plaque, a wonderful plaque, and a cash award of $200. And after a few years, he didn't give out the $200. It was just the plaque that you got, which was, again, probably worth at least that much.
Because I know you got that one three times, 78, 85, and 86.
Yes.
Well, just looking at the amateur tallies, Make Mayer has a COCD homepage, and he lists since 1990 at least all the discoveries each year and how many amateurs do it. And the last visual one would have been yours, Don, obviously, in 2018. Because, prior to that was 2010, so I'm guessing that one of those two were yours again. And then we have to go back to 2006. But the amateurs are still doing well. I mean, since 2013, there's been basically nearly 10 every year. We dropped off a little bit since 2018, but amateurs are still holding their ground against the big surveys. What do you actually think of all the survey? I mean, I know they're out there to basically find asteroids, but what do you think that they're gobbling up? You know, the people at Pan-STARRS and Atlas are doing an awful lot of. I mean, Pan-STARRS seems to have gone off the boil a little bit. It seems to be Atlas popping up a lot now. What do you think to those big surveys getting all the comets, and comets are not getting the names now, like, you know, Your Good Name and the Lovejoys and the Austins and things like this?
Yeah, those were the good old days. Catalina does a good job too down in Tucson area and a few other places. They had some fires in the area and so on, but that has been resolved, so they're back in business again. There's three things that are necessary for you to find a comet. One is to be looking in the right place, 40,000 square degrees. So if you go out tomorrow, where would you look and where would the comet be? Secondly is magnitude. You have to be able to see faint enough to see the comet. And there's been a few times that I've swept over a comet that was later discovered because it was too faint. And the third thing that you need, besides the position and the brightness, is the timing. You have to find it before it's found by others, because once it's found, you can no longer discover it. And of those three, it's the magnitude that we suffer with the large surveys, because we can go where they can't go, and we can go where they go. We can cover visually more of the sky than they can. And timing, we can get out there as often as they can. But it's magnitude. They pick it up while the comet is still very, very faint, well below what we can see visually. And so that's the advantage that they have. They pick them up a year or two before they get bright enough for us to see. Yeah. But you look at some of these comets, Comet Swan that was discovered just a few months ago could have visually been discovered in the morning sky. 35 40 degrees, 50 degrees from the sun at about 7.5, 8th magnitude. But apparently no one visually searching. It would have been visible for only about a week or so. Maybe even fewer than that days until Swan found it. If Swan had not found it, it would have been hanging out there for a while. Yeah. You do have fewer visual comet hunters out there. And
this is it, yeah.
I'm doing it. David Levy says he goes out from time to time to visually comet hunt. And there's only a few other people compared to back in the 60s and 70s when you had maybe 100 people around the world who systematically visually hunted for comets. And if you look at the names of those who did find the comets, probably 30 or 40 people were actually finding comets over the course of those decades. Yeah. But the search surveys steal the comets that we would have found. And that's why visual comet hunting is kind of coming to an end. It began with competitive visual comet hunting began with Charles Messier, who found his first named comet in 1759, and he found comets over the next 40 years. And he was the first person to visually discover 12 comets that bear his name. I'll probably be the last person to visually discover 12 comets that bear my name. David Levy's visually discovered 9. If he finds one or two more, that'll be great, but, it'll still be less than 12. And Fujikawa is next with 7 visual discoveries, but he's using CCD now. So we're really winding down in the era of visual comet discoveries. It's kind of sad to see that time go.
It is. How many hours have you got in this year, Don? I know it's been a horrible year, but, I'm sure there's been plenty of times you've been out there. I know you've not been well, but have you done much this year?
Done about 120 hours this year. And since I began in 1975, 8,666.75 hours.
Holy moly.
When I began comet hunting, I decided to count hours and not comets. I had no say over whether or not I'll find any comets. I could sweep all day, all night, and if there's no comets there, you won't find any, and you don't have any control over that. But you can control to some extent how much time you spend. So I count the hours, and I know that discovery is by chance, and that discovery can happen at any time in any part of the sky by anybody. But you can help your odds by doing the things that put you in a better position to discover the comets. And so that's what I try to do. I try to get out every clear moonless morning and sweep a different part of the sky. And after I've done that, I'll go back and re-sweep areas that I've covered a week or two before.
One question is, everybody's, of course, the biggest controversy at the moment, of course, is those awful internet satellites that are being put up. Do you think, as a visual observer, there will be less of a hindrance to a CCD observer?
Well, visually, it's not a bother to me. I know that the CCDs can be affected by it, especially when they're first launched and they're quite bunched together. And we've seen some of those photos where you just have satellite after satellite streaking through the image.
Yeah.
Most of the time, however, there aren't that many. I mean, as they spread out and so on, of course, there'll be more and more launched.
Yeah.
Yeah. It does make it difficult for the search surveys, especially in the twilight times as they're down toward the horizon. The places, again, where I look, but it affects them more than it does me.
Interesting.
What was, just we haven't actually asked you yet, Don, what was the very first comet that you ever saw?
not too sure about that. I missed Ikea Seiki in 1965, even though that was the week I got my first telescope. I didn't know it was there. I remember Comet Bennett, 1970.
Yeah.
Great comet, morning sky, March of 70. I invited my physics class, high school physics class, out to look at it. And 3 of us showed up at a park at 4 a.m. to look at the comet.
Wow.
Had a great time. I took pictures of it. First one I photographed. There might have been a couple I looked at in the late 60s, but Comet Bennett's the first one that I remember. It put on a good show. Bennett and I communicated a few times after I began comet hunting, and when I discovered my first comet, he sent me a telegram. Congratulations. Very nice of him.
Yeah, definitely.
What are your views on robotic missions to comets?
I think that would be great. We've seen with 67P the material blown out from a comet. Like 96P, for instance, when 1990, I discovered it in 86. 1990, the first few articles came out about it. And by the way, there's articles written about 96P every few months, either how they relate to comet or something, or how they relate to meteor showers or whatever. But the theory was that only 5 or 10% of the surface, nucleus surface, was active on that comet. And if it's, say it's the South Pole, and if the South Pole is aimed toward the sun as it heads in, and then it whips around the sun, a very hairpin type of orbit for this comet. Now the North Pole is aimed there, and it's not active. It would look like the comet is shutting down. And every comet's different. Orbital periods are different, and even the orbital axis will change in time. But I wish every comet could have something sent to it so that we can see what percentage of the area is giving off material, what size particles are given off. Some it's like the snow stuff, and some it's bigger stuff that's thrown off. I've read articles about 96P, and this is unbelievable, but from what I read, material is blown off of 96P at up to 50 meters a second, which is really fast. Not fast to be blown off of a comet that fast. And also, if we could also study the density of comets. Some comets, I understand, are lighter than water. I mean, like, what's up with that? It's like rubble or something, and snow. Is it all snow all the way through? And then some, of course, are much more dense. And then we have 96 or 67P was two rocks connected together. I mean, that's kind of an odd thing too. So I wish we could send a spacecraft to every comet and follow it in, stay with it as it goes through perihelion, and then follow it back out again, and just see how it behaves.
Well, I think we have a better chance of seeing that in the next few years with the European Space Agency's Comet Interceptor mission. So far, they've said they're going to build 3 probes, which will be launched and put at various points within the Earth system, so that they can be used to intercept comets. Now, it's been guaranteed. It's been said that it's going to be definitely a go. So obviously they're working on the hardware, and it's now just a race to get it up, because we just, as everybody knows, we just don't know when we're going to get something really, really fantastic. Of course, the last return of Halley's Comet really did kick off remote visiting comets. Giotto really did lead the way with the Russian Vega probes. There were 2 Japanese probes as well, and of course it really opened up just how much information could actually be found by sending a space probe. Then we had Rosetta, which was supposed to go into a completely different comet. And I think in the end, the best comet won out. Because the simple fact is, we were faced with what some of the tabloids nicknamed the rubber duck comet.
Yeah.
And of course, with that comet, we actually did the very first attempt to land a space probe on it. To send back. Obviously, it was a bit of a disaster, but it still gave us some information. It taught us an awful lot about attempting to land in the gravitational fields of a comet. And I think if it wasn't for that, we wouldn't have had the success with the Hayabusa 2 mission, which has successfully landed. It's dropped its little robots there. And of course, we have the other mission NASA's involved in. Oh, I can't remember the name of the asteroid now. Bennu, is it? I think.
Yep.
And of course, that again is supposed to be a sample mission. So really, Rosetta and Philae taught us so much, which we've very quickly followed up with when we go into other places. In the past, we've had to launch projectiles at asteroids to try and get debris, or even do it to a comet. I remember the controversy that caused a few years ago.
Yeah.
But as I say, we've learned so much in the past few years. If you had an unlimited budget, Don, and a chance to send a space probe to another object in the solar system, where would you go and why?
Well, I would choose 96P because it goes all the way out toward Jupiter, around near Jupiter, and then in the course of 2.5 years comes all the way on in to 8 times closer than us.
Yeah.
And so it heats up very quickly. Last time it was here, Soho found 3 fragments in front of it. The time before, they found 2 fragments in front of it. So doggone it, looks like that thing's fragments from time to time. Those were very tiny fragments, so it's not like it's fracturing into any big, not falling apart. But somehow it expels these materials. And then also I've noticed on the SOHO images, and I don't know if I've ever heard anyone else mention this, but when you watch 96P go through the SOHO images, you can tell on the very bottom left what the time is, and you can tell when it goes through perihelion. It has always looked to me that after perihelion, it brightens up within a few hours after perihelion. So I would be interested in knowing why it does that.
Yeah. I'm also interested, Don, because I've just been having a quick look at the JPL site, and when you discovered it, it had made a close approach to Earth of 0.4 astronomical units in June of 86, but it had also done that 4 times prior to that, between 86 and 1902. So I'm just wondering why nobody else had picked it up, as it had made such close approaches to Earth. I would have thought somebody else would have visually grabbed it.
You mean 96? This is 96P,
96,
right? Yeah, okay.
Yeah, 96P,
yes.
Yeah.
Dan Green mentioned that in, I believe, one of his articles, and this is why. When its period is 5.25 years, every 21 years it repeats where it was 21 years before. So we have four different times in which it comes in, and the Earth is at certain places. When I discovered it in 1986, we were well placed that post-perihelion, that is after it went around the sun and moved away from the sun, it was well placed in the northern hemisphere morning sky with fairly good elongation while it was still fairly bright. Other times, however, it's not well placed. If it comes in from behind the sun and whips back out, it has 2 things going against it. 1, low elongation. 2, it's only bright for a few weeks. So on each orbit, it's only discoverable for perhaps 1.5 months of time. And number two, usually when it's discoverable, it will be very close to the sun. So that's why now if we had SOHO up for the last 50 years, we would have picked it up because it's always in SOHO every time it comes by. But for us to visually discover it, it normally would need to be further from the sun. And that's why it was missed. And you could have a week or two in which it might be in, like when I discovered it in '86, if you had moonlight during that time, you don't like to go out when the moon's more than 40% full, so you miss a week there, then you have bad weather, you miss another week, and it'll be 5 years before it comes back again, and then it will be somewhere else in the sky. So that's why it was missed.
Interesting.
Yeah.
And of course, there's always the chance that it's probably daytime as well for the observer, I would have thought, perhaps.
Yes. Yep. When it's so close to the sun, yeah.
But it's a big object, isn't it? It's been estimated to be about 6 kilometers in diameter. So, and as its magnitude, its absolute magnitude is 13 point something. It's obviously a comet that is, how should we say, burnt, well, obviously because it gets so close to the sun, it certainly expends a lot of its volatile materials, and it is on its way to, decaying away, isn't it?
Don't say that. It makes me feel bad. No, I suppose it will eventually, but it's been holding up pretty well since at least '86, and it doesn't seem to be dimming much. I know it loses a lot of material, but when it's 6 kilometers in size, it can hang around for a while.
That's it. I mean, a comet like, for example, Encke's been noticed. It's dropped several magnitudes, hasn't it, since its discovery? You can. I mean, I think it used to get up to magnitude 3 in the 1780s. Now I think you're lucky if you get 5 or 6 out of it. So it's these close perihelion passages and repeated returns are not good for comets' health.
So I'm looking here now. The Tissard parameter with respect to Jupiter is about 1.94, so it's classified as a Jupiter family. Now the interesting thing is the orbital resonance with Jupiter is 9 to 4, and the next real good close approach to Earth will be 2028, and that will be at a distance of 0.31972 AU. Or 29,720 million miles away. So with luck, touch wood, touch wood. We should get a very good show, and it will certainly look very good in medium size to large size telescopes.
Yes, and that would be similar to the positioning that we had in 1986. So it will be against a fairly dark sky, elongation at least 40 degrees or so. It'll still be 9th, 10th, 11th magnitude at that elongation.
It's definitely a comet to put on the list for remote imaging as well, because the nice thing about having access to remote telescopes is that you can go for deep targets which are very dim at the moment, but with using blink technology you can detect them yourself at home. You can get blink comparator software very, very easily. The University of Wales here in the UK actually has a program that it shares as freeware that allows you to load up a whole series of images and blink them to see movement. And I know that it's used in classrooms to show the movement of Pluto. So recovering a comet that way should not be very difficult. And as I say, given how camera technology, CCD camera technology, is just jumping forward all the time, it's going to make it much more interesting for an awful lot of people who are like myself. my vision is getting to the point now at night that because I wear trifocals, trying to find the sweet spot on an eyepiece is murder. So I image, and that allows me to. Last time I checked with the system I'm using at the moment, I can go down to about 17th magnitude if I'm really lucky and there's no moonlight. But again, it's a case of I'm going to be sacrificing my computer to doing an awful lot of image processing just to actually have a single picture with that comet in it at that magnitude. But it's worth it. It's good fun, and I suppose one place where everybody can have do some great work is in comet recovery. You know the orbit, so it's just a case of looking along the orbit for the comet and being able to start the ball rolling. Really, okay, Pan stars, etc. They have the money. As they say, they have the detectors. They're always going to beat us, but just making the effort to be able to actually do the recovery as an amateur observer and imager allows you, or gives you the skills again for the various pro-am collaborations, and they're really. There's one currently going on with with the AVVSO. I always get those initials mucked up. So that they can, the Hubble team can use the Hubble on variable stars, because AVVSO members go out and do the light curve that allows them to see when it's safe to turn the Hubble onto the object. Or image in that area. So the skills are there, and I suppose really we can take part in comet recovery.
Yeah, I tried doing that with SLU.
Yeah.
I'm a member of SLU, and they have several telescopes, including half meters. And I began looking for 141P about 5 months ago. And finally, it was picked up with Pan stars at 20th magnitude.
Yeah.
And I think SLU only goes down to 15 or 16. I thought on a couple nights I had a suspect, but I could never really confirm that. And if so, it would have been brighter than 20th magnitude. Now, as for comets being seen at aphelion, Dr. Marsden told me a story about in the early 1990s. He said that Karen Meech, an astronomer, had some time on a big telescope in Hawaii. So she contacted Dr. Marsden beforehand and said, I've got this telescope, I've got all night. Do you have any projects I can do? And he said, here's 10 comets at aphelion. That is our furthest distance from the sun. See if you can see any of them. And night progressed. At the end of the night, she said, I found only one that was 96P, all the way out there near Jupiter.
Because 96P is actually just gone past aphelion, hasn't it? It's now starting its way back for 2023.
I believe it is, yes.
Yeah.
If you had a big enough telescope, you can see it.
In fact, Don, I'm going to put my hand up here and say, yes, I've seen some of your missions on SLU.
Okay.
But,
Has there ever been a time, Don, when you've missed a potential comet discovery? Say, for example, you had bad weather and somebody sneaked in where you would normally be looking, and have you ever been close but no cigar? Or
Yeah, Comet Kohler, 1977, early September. I was at a church convention on a Sunday night, and Monday was my first night of comet hunting because of that. So I swept a little bit south of where Kohler found it, and then the next day I would have been sweeping where he found it, and I get the telegram the next morning that he had found it. So if we had backed up a day and I was out Sunday night, and Monday night, same day he picked it up, I would have picked it up. But I've also swept over comets that were later discovered by others. Comet Takamazawa, a periodic comet found in 1984. I swept over it 9 times in the previous 2 or 3 months before he found it. And that comet appeared to have outburst before he found it, and on subsequent returns it hasn't been always seen. So that's a comet that varies in brightness. As we go through the book, A Decade of Comets, on my podcast, Looking Up with Don, over the next 10 weeks or so, beginning in 2 weeks, we'll be discussing the individual comets. And in that book, I do write when I missed comets. And I was rereading parts of it. And of the 33 comets found, probably 4 or 5 of them I swept over prior to the discovery and did not see it. Again, it was probably fainter than my light grasp. And on Comet 141P, this is my second periodic one, in the week before, I probably swept over it or to within a degree of it twice. And that's just the way it goes. You choose what areas you're going to sweep. And in this case, the comet was moving from south to north. And one day I covered the northern section. And a couple days later, I covered the southern section. So it kind of squeaked in between the cracks there.
Yeah.
And then I found it about a week later. But that happens, you know. And I'll tell you, it's very frustrating and depressing when that happens.
I bet.
You were sweeping there and you missed it because it was too faint. Comet Iwamoto, which was discovered earlier this year with a CCD at about 12th magnitude. I swept that area the day before Iwamoto picked up the comet, and I didn't see it, but it was kind of faint and kind of down by the horizon. So, you know, those things happen. Those things happen.
They do.
In fact, whilst you were talking, Don, I just looked up the podcast and I've marked it as following, and it's on my I've just saved the link to it as well, so I will put this into the show notes as well.
Well, thank you. There's two there's a feeling and a thought that I have with every comet discovery. It follows all of my 12 comet discoveries without exception. One is a feeling of humility that, in fact, a comet, a big comet, was discovered by me and it's going to bear my name. I mean, that's a humbling feeling. And it hasn't changed in all these years. I've always had that feeling like, you know, what, me, you know? I mean, you don't necessarily deserve that, and yet, you know, it's named after you. And the other is the idea that actually discovering the comet was pretty easy. It's just a matter of looking at the right place at the right time and being able to see faint enough. All of these comets were visible in my telescope, and some were 9th and 10th, even 8th magnitude. Almost anyone can see objects that faint in their telescope if they were looking in the right place at the right time. And for me, it was just doing my comet hunting. I mean, my first comet took 691 sessions before I found it, but I was there at the time the comet was there, and I was looking for it, and when I saw it, I knew, you know, it was plainly, obviously visible. And you get done, you think, wow, that was kind of easy. I'm just doing my thing, and the comet happened to be in my field of view. That can also lead to a dangerous situation where you think it's so easy that for the next week or so, you really have to control yourself that you don't report some false object that you think might be a comet. Oh, this is so easy. Now I'll pick up another little fuzzy object, which is 2 or 3 stars close together that appears fuzzy and doesn't appear in any catalog. But, you know, you got to check for motion. It doesn't mean everything you see from then on is going to be a comet.
I'm actually looking at the current podcast is number 34, Visual Comet Discovery. And so that's going to be listened to tomorrow.
All right.
I'm going to be on.
I talk about Dr. Eberhardt.
Yeah.
Dr. Eberhardt and his study of comets.
Because this is the comment. The description of the podcast is this is the type of study that helped to direct comet hunters where to search, and there's a download. It says Comet Discoveries and Observational Selection download podcast plus map. So they've had 40 hits already.
And when I began comet hunting in 1975, I did some study beforehand. You always count the cost before you get into something. And the BAA had some work done on comet discovery positions. I remember Hendy was his name, Hindy, did some studies on comet discovery positions, and that helped too.
Of course, the interesting, going back to the binoculars for a second, one of the things that always amused me was when George Alcock used his binoculars to find his comets, he was actually sticking them out of the window. He didn't actually go outside properly and have them set up in his garden. He used to actually have them stuck out of a window in his home. And most astronomers would be aghast because the heat rising from around the home at night probably would have distorted the field of view terribly, but yet it allowed George quite successfully to discover comets.
Yeah, with lower magnification, though, it's probably not that much of a problem. And also, you can have some unsteady skies, but still pick up nebulous objects. My binoculars, the wood box and the inverse U-shaped pipe that holds it weighs 120 pounds. So it has to be on a mount.
Yeah.
But I did construct my observatory, roll-off roof observatory in Colfax, California, so that I could just open up a side window and keep the rolled-up roof rolled up and point the binoculars out to the horizon, and I would do that sometimes.
Yes, the last time I tried to pick up my telescope on my own, I nearly put myself in hospital.
Oh, not good.
Well, I have two telescopes. I have a 16-inch ultra lightweight Dob. It's lightweight, and I can literally pick up the truss and everything by myself. I can't pick up the whole telescope on my own, not with the weights attached. So that's to get that out of my radio amateur shack at the moment, where it lives because of the bad weather we're having in the UK at the moment. It's a two-person job to take the complete scope out together. My other scope was a 10-inch Newtonian on an equatorial, and again, the weight of that was something like 95 kilos. It certainly was not. You would certainly take the counterweight off if you wanted to move it on your own. So one of the best things about binoculars, and this is something I always tell people, don't buy a telescope straight away. Buy a pair of binoculars, because you can get some very decent binoculars. They'll certainly allow you to see bright comets. They will let you see Jupiter and the Galilean moons. You can crater hop all over the moon, and you can definitely see Mars and Venus. And at least then, if you are still keen and wanting to go ahead, that's the time to buy a telescope after spending at least a year or so with a pair of binoculars. And if you buy astronomical binoculars, you're going to really want to put them on a mount anyway. Most people have a camera tripod and use that method. I actually used, for a while, I was taking photographs of the moon with a spotting scope and my DSLR attached to it. It worked. Where I previously lived is in upstate New York, very light polluted, and shining a 1 million candle light torch at the street lamps to put them out is frowned upon. We have been given other methods to control light pollution, doubtless to say I did not dare use them. I could probably get away with a laser pointer to some point, and I actually tried that recently on the street lamps around where I live now, and it does work actually. It does fool the sensor for quite a while. Gets all nice and confused and switches off. So I guess that's non-lethal and non-damaging, the same as the torch was.
Yes.
I think the torch gave me at least 2 or 3 visits from the local police. When they realised I was an amateur astronomer, they kind of said, "No, we don't really want to go around there anymore. We know what he's doing. We know why. We're not interested. As long as he doesn't shine it on aircraft or something going overhead, we don't really care." So there's a lot you can do. You can get brighter comets, of course, in built-up areas too, which is nice. It gives people a chance to see something beautiful at the end of the day. But as I say, I really think, well, it's always been my opinion, and Neil knows where I got my opinion from, don't you, Neil?
Yeah.
That binoculars are certainly the best thing, and of course, as yourself has shown, you can find comets with them. George Alcock did it. So if you're really keen and you know your sky, then you do have the chance to do it yourself, looking into the areas, as you pointed out, where the surveys don't go. Oh gosh, I've just looked at the time, Neil. We're heading towards another long show. I'm going to get told off again.
Yeah, we do this. We get carried away. We enjoy ourselves too much.
Absolutely. And of course, when we got great people like Don on, it just the chat is just that, and of course we just lose track of time. I'm now we're looking at 1 hour 41 minutes. Can you believe it? Since we started.
Right.
Yeah. I think the record's 2 hours, two and a half hours so far. But
oh my lord! Yes, that was Mr. Alan Han and Jim Scotty and David Eicher, I believe.
Yeah.
That was way back.
Yeah. We occasionally creep close to it, but it's all good fun. Just trying to think.
I was just going to ask Don what his favourite comet was that he's ever seen.
I would say Hale-Bopp. It put on a good, extended, long show. Did a great job. But there's other comets I remember too. Comet West, Comet Yakutaki. In fact, Comet Yakutaki, I was giving a talk on a Saturday morning in Berkeley, and I lived like 2.5 hours away. So I had to get up early in the morning to go. And I stepped outside. It was still dark outside, but it was foggy.
Yeah.
And I looked up in the sky, and I could see 3 things. The star Arcturus, the star Vega, and the nuclear region of Yakutaki.
Yeah, oh, yeah.
That's how bright it was. And of course it had a good tail on it too.
Cool, yeah. I think it was about 80. I remember looking up in the sky, and because we had terrible weather here in England in that March, and the lucky thing was the only good night was the night of closest approach to Earth. And you know, I could see that. I mean, I just looked up at the sky, and then there's this huge tail going across it. It must have been at least 80 degrees or so. You know, very bright head, and then the green colour, turquoisey blue. It was unbelievable. Did you ever have memories of the Iris Iraqi Alcock Comet of '83? That's a bit before my time, but did you ever see that one? I believe it moved quickly.
Yes, and that and some other comets will sometimes suffer from what's known as the delta effect. That is, as it gets closer to the Earth, it becomes larger in size and harder to see. And Alcock did that. There was another one found by the 3 Japanese astronomers shortly after that, which came almost just as close, and that does it too. But yes, Iris Iraqi Alcock. And the surprising thing was you could notice the movement over the course of a few minutes.
And of course, it's also, I suppose, famous for the fact it was also discovered. One of the discoverers was the infrared satellite IRAS, and of course that really did turned people's heads because no one had bothered looking in the infrared for comets, and then suddenly,
Oh.
during an infrared survey, they found a comet.
Yeah. By then, comets had already been found by satellites with the SolWind comets back in the late 70s. But yes, Iris or Rocky Alcock found several.
Yeah.
Iris found several.
And what did you think about the Borisov comet, the interstellar one, Don? Did you ever think that an interstellar comet would be 100% bona fide observed in our lifetimes?
I was a bit surprised to hear about that. And yes, that is a bona fide comet from interstellar space. And we can tell that because of the eccentricity of the orbit.
Yeah.
However, remember my last one I found, 2018 V1. An article came out about a year ago saying that comet could have been interstellar, and other comets which have an eccentricity of just a little bit more than one, they could be all interstellar too. And
and possibly 96P as well.
Yeah,
yes, might have come from a different solar system too.
Beat me to it, Neil.
But
What is
this
your
last
thought
one
on
that
that,
you
Don?
mentioned, definitely did come from a different solar system. Yeah.
Yeah. What do you think to the 96P? I mean, because some people think it's interstellar. Some people think it formed in a part of the solar system in a much colder place than normal comets. What do you secretly hope it is or think it is?
I don't know a lot about these things, but it would be interesting if it came from another solar system. And I read somewhere that if it did, it could have spent 1 billion years traveling from there to here. That's amazing.
And you discovered the first one, if they can prove that.
Yeah. Yeah.
Well, the interesting thing about 96P is it's carbon and cyanogen depleted.
Yes.
Very strange.
Yeah, exactly. The chemical composition is one of the things that implies the possible extrasolar origin for the comet, because we know we're fairly aware that any comet that's originated in our solar system, the chemical markers are known to us, and we know what to look for. But this one, this has a chemical composition which is definitely very unique, and
Definitely, yeah.
It really, in some respects, is really great because it means that what we used to think everything came from the Oort cloud or from the trans-Neptunian area, but now we've got stuff which, through its chemistry, we can prove to maybe have actually travelled from another solar system. So it gives us perhaps a chance to look at the chemical composition of an extrasolar system, probably not even reasonably close to us. As you pointed out, we don't know how long it's been travelling.
No.
I don't think it's from the Alpha Centauri system. It'd be nice if it was, but that would be perhaps too pat.
Yeah. It'd be interesting to see what the Borisov chemical composition was compared to 96P as well. I haven't read anything about it. I know they've done some, work on it.
They've tried to do some work on it, but it was going so fast, and by the time it was discovered,
yeah.
But
it'd be interesting to know. But there you go. But the last one that I saw, Don, was the 2018 discovery of yours. In fact, that's the only one of yours that I've actually seen, because I missed the 2010 and 4. 96P, obviously, I've seen it loads of times in Soho, and if anybody's listening, they should get the Soho pages up and get the 96P perihelion time on the film files that you can download and watch. Those are amazing.
Interesting.
The year 2002 was especially spectacular in the Soho images.
Yeah. It's an amazing object. You must be very proud of that. Sorry, Nick.
It's a good comet. It's a good comet.
Yeah, I was about to say that the eccentricity of 96P is 0.95912, which is
Wrong for a Jupiter family comet.
Yeah.
Completely.
but it's captured by Jupiter now anyway. So,
Yeah.
but I think really that does this is a label that's saying, okay, I'm captured by Jupiter, but I've come a long way, because it is kind of close to Borisov's eccentricity too. And we've been able to backtrack that a fair bit to prove that it's extrasolar. So,
What did you think to Oumuamua, Don? Are you of the belief it was a comet or an asteroid?
I don't know what that was. It was too bad we weren't able to get more views of it and get it on its way in.
It didn't do a lot, did it? It just shot through, didn't it? And
Yes, we have difficulties, as we mentioned earlier in this discussion, about what is an asteroid and what is a comet. And this might be somewhere in between the two.
certainly if it had volatiles in the past, they must have been fairly spectacular from its home system, I would have thought.
Yeah.
But getting stripped out fairly quickly, possibly, and then becoming an interstellar visitor to who knows where. We still don't really quite know where it's going. We haven't really managed to backtrack it enough to see where it's come from, which is a shame, really. But I think in future we'll get better at it. We're now capturing, for want of a better phrase, these interstellar visitors, and we're now looking at mostly in the right places. We know not to look in all the regular places, so everybody starts looking in where you would least expect something to come in, and perhaps that will allow us.
These interstellar objects are the ones that the comet interceptors are wanting to get a good look at.
Yeah.
How many of your comets, Don, are going to be ejected from the solar system? Is it 2 or 3?
Well, if this last one is, I don't know if this last one will be, but it did have a eccentricity greater than 1. The first comet I discovered also had, of all the comets I discovered, the first one had the greatest eccentricity, 1.00416, I think is what it was. So, but I haven't heard anything about, we just know it's probably, as Dr. Marsden says, if it comes back, it will be like 100,000 years. He says that for a lot of my comets. In fact, 4 of my comets, we have an eccentricity only to 1 or 2 significant digits, 1.0, because they weren't tracked long enough to get an accurate orbit. My second comet, which disintegrated, my 4th comet, which disintegrated, the one I found in 1992, K, was only tracked for 10 days or so, I think, of data before it got too close to the sun as seen from the Earth, and then we lost it. And then the one I found in 2010, they don't have an accurate orbit for that one neither. So who knows if they're coming or going, or if they'll ever even come back again, and someone finds them decades from now and, oh, that's that one. Now we have an accurate orbit finally.
Exactly, yeah.
Well, we are approaching 2 hours. Yeah, 1 hour 54 minutes. So I think it's probably best to let Don rest his voice, because I know that it's definitely been a fascinating hour and 50 odd minutes for me. I've quite enjoyed this.
Definitely.
Don, would you be willing to come back at a later date so we can just talk more with you?
Oh, yes, I'd love to. This has been, I've really enjoyed this. This has been a great time.
Okay, so I think probably the best thing to do, we're about 1 hour 55. I know that astronomy.fm is going to be giving me the dagger looks for how they're going to have to rearrange their schedule when they play this show. Yeah, that's okay. Neil and I do another show, Anglo-Irish Astro Geeks, and that second show was quite a long one as well. And they're taking them 4 days to try and figure out their schedules so they can put it in and start put it into their show for the next 24 hours after it originally goes out.
But we're also on YouTube as well, so
Absolutely, yeah. So
we have other outlets.
yes, the podcast. Actually, the interesting thing is the podcast does get shared literally mobile phone to mobile phone in some places. So
Yeah,
so we're doing quite
in
well.
Asia.
Yeah.
We're very big in Asia. Yeah, and Australia down that way. Yeah.
Oh, definitely. But then again, it's interesting that how word of mouth actually disseminates the information and stuff. So, right, yeah, I think this is probably a good point to end the show. Don, thank you so much for coming on. It's been really good hour and nearly 2 hours, and I've really enjoyed it. I look forward to our next chat, and I will put a link to the podcast and everything up on the show notes. Neil, any last thoughts?
No, I mean, I'm looking forward to the book. As you say, Don, that's going to be fantastic to hear and read and everything. So I can't wait, and keep listening to the podcasts. I urge everybody to listen to those because those are fascinating things and keep you up to date with everything.
All right. Thank you very much. I really appreciate this, Nick and Neil. You've done a great job. I've enjoyed this interview.
Brilliant. Thank you.
Thank you very much, Don. It's a great pleasure for us.
Yeah. So listen, all it remains for me to say is good night from him.
And good night from me.
And good night for me.
Good night, everyone, and look up.